Over to you.
Hello, everybody, and welcome to this episode's edition of Deep Dives. This time, the rules are flipped. I have the great honor of having been invited to kind of host the deep dive of Tellor itself. What an honor! Obviously, we have Nick here, who will be telling us everything about their project and their roadmap and everything they've been cooking up behind the scenes all this time while you've been following deep dives of other protocols. We can really like go into what Nick does in this video format, which I'm sure everybody will love, all the followers for sure. So without further ado, I would like to start with like easy softball question. How does Tellor start? Where does it come from?
And thank you. So, and by the way, for anyone watching this, Daniele, he is the same Daniele who was on the Ovix deep dive that we did. That was like almost a year ago now?
Almost a year ago, I believe so. Yeah.
So he has been on the show before, and he's a super smart guy. So figured we would get him to talk to me. But anyway, so how Tellor started. So so we've been around for a long time. So we were, I'm pretty sure a lot of people probably know the background of Tellor, but real fast, so we were building in 2015, 2016, I was working at the CFTC, regulator here in the US, derivatives and cryptocurrency also. And I started kind of on the side building a derivatives protocol. So we were trying to build long and short tokens. So one representing the long side, one representing the short side. And this was novel back in 2016. It was a great idea. Anyway, so I left in 2017. I got an Ethereum Foundation grant to try and build out this derivatives protocol. And as you guys know, Danielle, especially who works on building these kind of things, one of the hardest problems of having a futures or options contract is well, who says what the price is? This is the Oracle problem. So who gets to say, the price of Bitcoin is now $30,000 if you're trying to make a bet on it? And back in the day, in 2017, 2018, there was nothing. This was pre-Chainlink launch. There was Oracle Eyes, who I don't think I've had him on on the show, but I've tried to get him, and he will not. He is ghosting me. His name's Thomas, but he was like the only option available at the time, and or you could use like an auger pool. It was very, very inefficient. So we said, okay, let's go build an actually decentralized Oracle, and that was how we kind of got into the space of building an Oracle. The first version of Tellor was like proof of work. We launched in 2019, and we've kind of been iterating since. We moved to proof of stake. We've slowly picked up a lot of business as far as getting protocols who want some actual decentralization, and the rest is kind of history. So
yeah, I mean, I've always appreciated this angle of you guys coming from the CFTC into like very decentralized focus applications in the crypto ecosystem. So you guys definitely have that as a very unique angle to you guys. Like someone might even wonder, are you guys CIA plants of some kind?
Yeah. Well, I find it
so
funny, if you look at, now everyone, after these, the CFTC and the SEC are cracking down on projects now, and everyone's like, oh my God, we have to decentralize the front end, and we have to actually be decentralized. You're going to get shut down by the regulators. We knew this back in 2000. Anyone who was around was like, of course you have to. Of course, if you run a front end that trades futures and options contracts, you're going to get regulated. So we knew you had to be decentralized, and everyone back then did. Everyone just sort of ignored it in the last few bull markets. But we always figured that you would have to be decentralized, and that's sort of what makes sense. It's the whole reason we're here. So
yeah. Absolutely, and like I said, it's you guys are one of the teams that probably puts so much effort into really showing the importance of doing the hard work to get decentralization like in the real, like in a real aspect, not just in name only. So I think that's something that people should always like try to read into Tellor, and when exploring their project, like it's something that you guys put a lot of thought in. So how about you give us a brief outline between how Tellor was designed initially and what problems you found with it, and now we're going to use this as like kind of like a springboard to get into this new deployment of Tellor. And
well, so like
details.
I mean, the way that Tellor works currently, you know, I'll give you guys can go watch the video I did a year ago. It's excellent. But the way that Tellor works currently is you have parties who come and they'll stake TRB tokens, and then they're allowed to become reporters. So you know, you have Tellor tokens on top of Ethereum or on Polygon. You stake it in the smart contract, and then someone will come along and they'll tip. They'll say, hey, I'll pay $1 worth of TRB to whoever gives me the price of Bitcoin. All of those staked reporters will then compete to put on the price of Bitcoin. And first one to do it, he locks his stake with it for 12 hours, and he can be disputed. So if he lied, he's going to lose that stake. Anybody can dispute him, and he's going to lose it. And what this allows is basically anybody can ask you can ask for anything. Like if the tip's big enough, some reporter will go and figure it out. But it allows you can ask it any question. You can ask it as frequently as you want. And it's a really cool system for a completely decentralized Oracle. Anybody can come in and stake. There's no permissions. Anybody can come in and dispute. And it's very different from a lot of other Oracles who have trusted parties. If you've seen this show before, you know most of them have whitelists or some sort of, you know, person sort of standing in the middle, but not Tellor. Anyway, there are a few downsides to this sort of approach. The big one that we're sort of facing now is you're seeing more and more chains. So rather than, you know, like we had made the call back in probably like 2019, 2020, we were like, listen, we're going to be ETH focused. We think that the vast majority of activity is going to happen on top of Ethereum. How can we be the best decentralized Oracle on top of Ethereum? And it was sort of the right call. You know, most of the activity, especially in that first, you know, 2019, 2020, that was all on Ethereum. And now you're starting to see stuff move over to other chains. So how can we do that? And luckily our system was you could port it over to other chains, but we have the problem of you have to bridge your token over there. And that works for systems like, as you know, Polygon has like a native data bridge. Rollups, you can sort of do it, but it becomes really hard because they're actually competing with each other. It's still trustless, but if you have a bunch of people who want reports over on Polygon, they have to pay more because they have to basically outcompete the opportunity that's available on mainnet or the opportunity that's available on Optimism. So it like sort of, you know, it's even if like you are reporting like the Bitcoin price on 3 different chains, you still need 3 stakes for that, and it's rather inefficient. And we've realized this, and we're like, okay, so we need to do that. So that's kind of one of the big limitations that we're facing now. Also, people are moving, you know, this system that Tellor has right now of locking up a single stake for a value, that works on Ethereum where it's relatively slower data. But if you move to like, you know, an Arbitrum with half-second blocks or something like that, and you want a price that's updated every half a second, it gets really, really expensive for stakers, and they need to be rewarded for that. So it can be challenging. So like now to lay out, okay, so how can you solve these problems and where do we see the future going? Namely, we've identified like 4 basic things. So the big thing that's sort of developing, and most people know this with rollups, but it's the idea of trustless bridges. So if it kind of like came about with like light client bridges. So if you remember, like the Near Rainbow bridge was one of the first ones, and then, you know, Gnosis they've funded Succinct, which is, you know, they're doing ZK light client bridges. Cosmos has IBC, which is light client bridges between Cosmos ones, but now you can connect IBC to Avalanche, and probably within the next 6 months, you're going to be able to connect IBC to Ethereum. And these are all basically, you're reading the other chain's consensus, and you know what they did, and you're going to be able to read value. So if you assume granted, they're still relatively slower and more expensive in these trustless bridges, but that's That's a computer science problem. We're going to solve it. It's gonna we're going to live in a world where you can pass value back and forth relatively quickly, and you can pass information there. So if you assume that, the big question is okay, why would anyone ever stay on a crazy expensive chain? Like, like even if you're on Ethereum, like you have to really, really, really want to be on Ethereum if you're gonna put up with this. Like, because now you can have the big reasons that you wouldn't go to like a Cosmos chain in general. Like, it's near impossible to bridge. Like over the past few years, like if you wanted to go trade on a Cosmos DEX, it's like, man, this is. Like you better sit down and have a day ready because it's gonna take you a long time to get over there and a long time to trade through a bunch of assets to do it. So this is going away. So once you get trustless bridges, what we also see is there's going to be no winning system. You could say like the last sort of bull market and cycle, it was all EVM stuff. Like EVMs won hands down. I think that's going to be less important, assuming this one. Like you could build you can go over to a Solana. You can go. I mean, what are the crazy things Polygon's building now? Like, it doesn't necessarily have to be EVM based, and so like you're going to need, if your Oracle is a Solidity smart contract, it will make it very, very hard to port over to every other system. So we're going to we want to design something that doesn't necessarily necessitate EVM chain
compatibility.
Yes, like it's not just a smart contract. And the big thing that this is showing is like there's going to be app chains. So I think DYDX is pushing this. Like everyone obviously, whether you're on the roll-up thesis or not of there's going to be thousands of roll-ups, or you think there's going to be thousands of L1s, people are going off chains. This is how we're scaling. It's going, exchanges will be their own chain. Every, OVIX, for instance, I see that being, it's going to be a roll up or its own chain of some sort, and you'll be able to quickly lock value on there. Like in the same way you deposit money onto a smart contract now, it's just going to be the same and it's on somebody else's chain. And so for Tellor, like, as we were talking about the current Tellor of having to bridge Tellor tokens, if you have thousands of app chains, like the current system, like is very bad for that. Like it's just, you're reporting the same price on thousands of different chains and locking up value. It's not good. So we need something that fixes that. And I mean, the last point that we say is like, increase speed / security. Your Oracle needs to be secure up to crazy amounts of money. And it also needs the ability to be fast. Like, like the old days of like, like Augur or things like that, where like, if it could potentially be crazy slow, like, oh, we're just going to put on a price every day. Like, we'll have a Dutch auction every 3 hours for a price. And that could be your price Oracle. Like, that's awesome. And it's decentralized. And I love those game theory systems, but like, it probably won't work. It's
not practical.
Right. It's just not practical. So you're going to need to figure out something that is there. And then, I mean, to add like so this is like the future that we see, but then, kind of like pushing the principle of all of it is like, no matter what, like we're not compromising on decentralization. So like all of this, and I think like the future holds that, like everyone over time, like I've been around long enough, like you remember private blockchains, you remember like even like EOS, or every cycle there's somebody who, they try and sacrifice decentralization for speed. And
Hyperledger, remember Hyperledger?
Yeah. Every single time.
Back in the blockchain, not crypto days.
Right. Yeah. And like every single cycle you see somebody and they're like, listen, we're just going to come along and we're going to like, and they're like, yeah, listen, if we just have 5 validators, we can make this crazy fast and everyone will want to use it. And it's like, we know that you just missed the whole point. Like,
yes, exactly.
Of course you could be crazy fast. And like, same goes with oracles. Like you see people who are talking like, yeah, we're just going to whitelist, like 12 banks and then we'll be, a crazy fast trust, Oracle that you can trust and use for everything. And it's like, it doesn't make any sense. Like you can't do that, And so
at
like
that point, why do Web3 to begin with? You're just trying to rebuild Web2 using Web3 components, and that's like you said, it misses the entire point of
right.
of what we're trying to do here. Right.
Yeah, and I mean I want to make like a slideshow at some point, like of like, just all the countless times that banks or cartels of banks have like screwed people over the years. Because like, like to think that we're going to be any different, or that if you hand a cartel of people a bunch of power that they're not going to screw you over, it's just wrong. So like you have to be decentralized, especially on your Oracle piece. And as we start talking about some of the use cases that I see for Tellor, it's going to make it pretty obvious, like you want these things to be decentralized. You don't want them to be run by anyone. So
absolutely.
Okay.
Absolutely.
So that's setting the stage. How's that?
Yeah. That's amazing.
What do you disagree with?
No, I don't disagree with anything. So to be honest, and in like past conversation with you, like I've actually like my So I guess my angle on like alt chains and dApp chains has always been a little more skeptical than yours. If anything, you've been kind of like a crucial a point of contact with whom I've spoken with over the past year that has led me to like reflect on this and doubt my criticisms a bit more, because you make a lot of really good arguments for it. I'm personally still worried about the fragmentation, the risk that comes out of all these dApp chains deployment, even though obviously that helps with scaling. Then again, especially with zero knowledge proofs, I think this fragmentation becomes less of a problem over time, because as long as we can, as the different dApp chains can all agree on some standard of truth to integrate with each other, you can actually come up with a lot of really cool things. So like Keom lives in the Polygon ecosystem, and there, for example, the roadmap there is to effectively ultimately have all the chains kind of publish zero knowledge proofs of their state. Commit their state through a zero knowledge proof onto Ethereum mainnet. And so effectively, what is effectively possible is that with some degree of granularity, all the various dApp chains that are built around this ecosystem, since they effectively work off the same ZK cryptography, they work in the same zero knowledge cryptography framework, then effectively they can all prove statements of their state on each other's chains, meaning that you can open up, for example, having abstract accounts that manage liquidity across different chains simultaneously. You can aggregate liquidity, and this is part of like the Polygon 2.0 roadmap, for example. But so let's say that starting with a discussion that I've had with you privately, and reflecting deeper on some of the stuff being spun out through zero knowledge applications, I'm seeing the benefit out of these dApp chain rollouts, not just for scaling, but also for scaling within the context of reducing fragmentation while you scale, because that's always been like the risk in the past when spinning out especially L1s, alternative alt L1s. So this is great. This is a great setup. So now, where build the dApp chain? So okay, so you convinced me on having your own, how Tellor having its own dApp chain. Where is the dApp chain going to be built? What considerations went into deciding where you're going to build your dApp chain, and with what kind of developer toolkit? And just walk us through like the technical considerations that a CTO makes in this circumstance.
Yeah, so I mean, it's not a secret. We've said so. So we're going to be a Cosmos chain. As I had kind of pointed out in the other piece, like I don't think there's going to be a winning system in the future. Like this is honestly like the big reason that you picked Cosmos. So like we had looked into mainly there's tons of rollup frameworks that are super popular at the moment. You're either if you're building your own L1, the real options are, it's like, do you want to do like a Solana fork, an EVM fork, a Polkadot chain, or like or a Cosmos chain. Those are like the big ones at the moment. And then you have like, and then same with like if you wanted to be a rollup, the problem with a lot of rollups, it's like, so like you have like what you could be like in the op stack world, or like you could be like a ZK rollup. The big reason that we didn't really like we didn't really like any of the frameworks for rollups because like none of them are decentralized yet. Hands down, like there's not one that sort of fits our bar of decentralization. Like, like you could, like all of them still have admin keys, like they all talk about like, oh, we're going to have shared sequencers and we're going to, like be able to decentralize this. And it's like, it's all still in the future. And so you would be like a guinea pig for that, which is just, it was not something we necessarily wanted to do. And then, still the idea for me, like we did a really deep dive into a lot of these roll-up structures, and you have this idea of like, can you be a sovereign roll-up? And like you want, like we'll talk about this a little bit as we go, but the main piece is like when you have your own chain, a lot of your security comes in your ability to fork that chain. Like, like if the difference between like if you have a chain versus you have a smart contract, like if you have a smart contract on Ethereum and that gets hacked, it is gone. Like you cannot roll it back. There's nothing you can do about it. And people hack smart contracts all the time. If you're your own chain, like if you're Bitcoin, for instance, it's relatively cheap to attack Bitcoin. You could attack Bitcoin's proof of work for an hour for like $1 million, but nobody does. And like, why wouldn't you do that? The reason is that it's pointless. Like the chain would just roll back as soon as you're done attacking it, and you would, everyone it would be painfully obvious what's going to happen, and then nobody would accept it as final. And the same goes with Ethereum. Like if you were like, I'm going to buy up 51% of all ETH, and then I'm going to stake it, and then I'm going to break their chain, and everyone would just be like it would be very obvious what's going on. We would just be like, no, like that's not going to happen, and it basically negates the whole reason of doing this. And you have this sort of fight within rollups, like like Optimism and Arbitrum have more famously said like, we're sovereign chains. So like it's like what makes it sovereign versus like if you bridge your ETH over there, like do they have the ability to fork is the question. And they would say yes, they own their chain's data, and that like that's why their token is valuable. It's that they have they're a sovereign chain, and they can sort of move if they decide that something happened and they want to move as a community, they can do that. But then, okay, so if you are sovereign, then what's the point of being the roll up? It's like it's super tough, and then it's like it comes down like I think in some ways it's a weird question, because like if you're a roll up that checkpoints once a month, is that more or less secure than an L1 with a trustless bridge? I don't know the answer to that question. But like, and I think a lot of people are still figuring it out. So as people figure this out, we wanted to go with something that works. We wanted to, we wanted to go with something that was sort of battle tested. It can handle a whole lot. Like and this was Cosmos. Like if you're building an L1, hands down the most mature stack as far as if you talk to any team out there is the Cosmos SDK. It's
it's been developed. It's been under very significant development for quite some time now, and it can stress us quite a bit. And go ahead.
I mean, even like if you look like like some people are like, oh well, has it had value? Like if you remember the whole Luna thing, that was Terra was built on Cosmos, and granted it blew up, but it wasn't Cosmos's fault. Cosmos
of course
Cosmos worked
it blew up because of
no,
it blew up because of economic fallacies in the entire design of their base tokenomic model. For sure. It had nothing to do with the actual tech, the blockchain tech.
Yeah, but it was a great sort of stress test for the Cosmos system, for the Tendermint consensus, as far as can this thing hold billions of dollars worth of value? And the answer is yes, it can, and it did great.
Yeah.
And I mean, I think lots of people have slowly been moving more and more towards the Cosmos vision. And not to mention, like early this goes back, like we've been following Cosmos for a long time. Like back whenever we started Tellor, we were sharing an office in Berlin with some of the Cosmos guys, and they were actually influential in kind of the first design of Tellor. They had given us a lot of feedback. So We always had a special place in our heart with Cosmos, and like,
I didn't know that backstory.
Yeah, and if you think about all the chains, like those other L1s, like we don't need to bash any of them, but it was like which one is decentralized and fits like where we want to go with Tellor? Like it's Cosmos, that's like everyone else like is kind of not necessarily the vibes we're going for. So Cosmos vibes mixed with just it's by far the most robust. I think everyone, like if you look at even big teams where they're building, like Celestia is a Cosmos chain, DYDX is a Cosmos chain. These are brand new chains that are still building on it, and it's crazy fast. So anyway, enough time on Cosmos, but
no. Okay, so so putting aside the choice of what tech stack to build your dApp chain on, what comes next? How does Tellor change the moment it can be deployed on a dApp chain? How do you plan? How does it? How can it be used to connect more quickly and more efficiently with other chains to offer Oracle services to other chains? Let's go into effectively the new design of Tellor.
Sure. So like I'll draw it out here pretty quick. So for those that don't know, Tendermint uses its delegated proof of stake. So it's proof of stake, but you can delegate your tokens as well, assuming you want to do that. But Tellor's kind of like a three. The way that it works, so like with I'll kind of briefly explain Tendermint consensus, and you'll be able to kind of see. So like you have a bunch of validators, and they come on here and they're going to stake tokens. So they would deposit in here some tokens, and they would be validators. And the way that Cosmos works is you have a max number of validators in your set. So like it is the number of validators. So you would say like, do you want 50? Do you want 150? You could have 2,000 if you want. The trade-off here is that obviously as the number of validators go up, so does your block
time grows also.
So does your block time, right?
The consensus time. Yeah.
Yes. So like it's a configurable variable, and like right now they would say target somewhere between 100 and 200. Like not to mention the fact that the vast majority of your stakes are going to be in, a handful of people, probably a number much smaller than that. So you would target somewhere around those validators, and then everyone else can delegate to these validators with their tokens. And this is your
how many validators? What's the max validator set that you guys will be targeting?
I think right now we're looking at around 150 validators, and with that you could do like with that we could probably do about 1 second block times, which is okay. That's kind of what we're targeting. And there's a lot of experimental stuff. Like if you look, DYDX is doing a lot of experimentation. Like you could, I don't see it being weird in the future that this is going to get even better as far as like you'll be able to push this down to fractions of that time, and push the validator numbers up. So computer science problems were 1 second block times is way plenty fast for most EVM chains. So we're A-okay with it. Anyway, so what happens is a block gets proposed over here, and then you would go over to this is like the pre-vote stage. So basically everyone would check off on it, the block. So like somebody would get picked based on their weight to be the block proposer. He would propose this is the block. Everyone would give a check. Okay, this looks good. Like as far as the ordering and the transactions in the block. And then they would come over, and then this would be the commit. Basically, you would finalize. You would say like, okay, this is what the state change should look like in Cosmos, and all the validators would check off again, and then it would get added to a block, and then the cycle goes around, right? Right. Now, Tellor works in kind of the same thing, but it's like a 3-step phase to getting a report on Tellor. So the first piece is a tip. Second piece is a commit. And third piece is a submit value. So like we'll just use prices because prices are nice and easy to
intuitive. Yeah.
Yes, everybody knows what a price is and what we're looking for. So like the tip. So in this block, you know, like we can have a user who would like he would call tip, you know, BTC USD, and now he wants a Bitcoin price pushed on. Everyone would see this tip in one block, and then in the next block, what they would do is anyone who wants to, so you don't have to. This is where Tellor's different. So other oracles, you know, if they have their own app chain, what they're going to do is they'll just say like, listen, we provide Bitcoin US dollar, ETH US dollar, and these ones, and the validators are just going to sign off on a pool of APIs, and that's it. You know, and they all run the exact same APIs, so we know what a good price should be.
Right.
That's not how we work. We want it to be more decentralized, and we want you to be able to ask anything still. You should be able to ask anything, and they also shouldn't have to sign off on it, because like a lot of times, like if they ask for a Bitcoin price, if you're not sure about what the Bitcoin price is, if it's weird, we allow you to not respond, which is different. Anyway, so now what everyone's going to do, all the validators over here, so this would be block 1, and then in block 2, they would all basically put in their array of values. So, you know, if there was like a Bitcoin and ETH and a TRB price, they would put, you know, an array of values with their commit. But it would be secret. So, you know, like everyone would commit secret value. So it'd be like, basically you would sign the price, but nobody would be able to tell what it is. And the reason
the hash of the price, so everybody's pushing the hash of the price.
Yeah, because you want it to be secret, because the problem is like, you know, what you don't want to happen is mirroring attacks. So like you wouldn't want everyone to see, oh, the Tellor team reported that Bitcoin is 30,000. I don't want to get slashed for submitting a wrong price, so I'll just say it's 30,000 too, and then nobody actually checks the price. So you have to keep it like secret, just to make sure that they actually go and check said price. And then obviously
there's a signature.
Yeah.
So they're committing a signature.
Committing a signature that says I'm going to reveal what this is next block. So then obviously in the next block, what you would do is you reveal it. You reveal, and then after the reveal, what Cosmos allows you to do so like you submit reveal, and then the block proposer down here would aggregate. So he would take all of these revealed values and he would medianize them and produce an official value. So we're going to use, you know, weighted median for most, unless you specify otherwise. So like when you tip it, you could specify a different aggregation method, like if you wanted the mode or the mean or the weighted average or something like that.
How do you? So effectively, there's no check for how much volume is behind the price quote that each validator submits.
No, I mean you could request a volume, and then you would have to handle that kind of on your own end.
Yourself. Okay. Right.
Yeah.
Okay. And what's mandating that the price quoted by the validators is actually read from somewhere real and isn't invented?
Yeah. So this is kind of similar to the current Tellor design in that it's very, very different than other oracles in that, you know, we don't mandate. What you could do is you could say like, you know, like I want the Bitcoin US dollar as the median of Binance, Coinbase, and Kraken. You could say that. The problem is that the more specific you get, actually, the easier it is to kind of manipulate in a lot of ways. Particularly like if you're doing these things on exchanges. So what we say is like the base Bitcoin, you know, you could specify that in your tip, that this is the price I want an aggregate of these APIs. But for like a base Bitcoin US dollar price, we actually let you pick kind of your own source, and then it goes to disputes. Basically, we allow the system to dispute you. So this is where we're kind of different than a lot of other oracles, where you just, if these are whitelisted parties, there's no disputing them. Like you can't dispute them. What you would want to do is you would want to come and we have a system on the side that would say, for disputes. So what you can do is if somebody pushes a bad price, you can come in and dispute them. And should we go over the dispute process now, or?
Yeah, actually, yeah, because I was about
Okay.
to, I was about to, yeah, for sure. Because I'd love to know, for example, it should be explained at the very least. A, how dispute functions just in general. B, how in countering, in effectively disputing a previously pushed price, how do you prove that what the real price is? Obviously, I imagine it has to do with it's going to be like a voting mechanism across all the validators. So yeah, walk us through the dispute process. So you just, Alice just asked for the BTC USD price, and I say the price on Coinbase right now is $20,000.
Right. So before we get there, I think the other piece is, so the way that Tendermint works too is you need 2/3 of the validators to sign off on something for it to be finalized. So like it has this fast finality thing. So like we have this idea of like, so like you can reach consensus on a value. So like if 2/3 of the validators report this Bitcoin price, like you reach what's called consensus. And, like we would really hope that, or, like it's going to work out that like you're not, if you submitted a bad Bitcoin price because you're being malicious or your API went down, you're not going to be the median here. Like it's, like the whole system would break if you controlled 2/3 of the vote weight. So you would be off on the side and not part of this. But the idea is that you could also be an optimistic value. And this is kind of how the current Tellor system works, where we submit a value and then you should wait to read it to see if it's disputed. And the reason that we do this is, like, let's say Bitcoin US dollar, or let's say it's not Bitcoin US dollar, let's say it's some shit coin that nobody wants to trade. None of the validators know where to grab this price, but there's a giant tip for it. So like one guy, he's going to go and he's going to submit a value for it. We don't necessarily know if it's right. He's still subject to a dispute on that value if somebody wants to come and dispute him, but you can still use it in your protocol. We would just say use it optimistically. So you would be able to tell that not all of the validators signed off on this. You could tell the vote weight, and then you would just want to wait and check, did this thing get disputed? And that would be how you would use these. And the other cool thing it could be with like a Bitcoin US dollar price, like if, let's say Bitcoin on Coinbase, it flashes up, and on Binance, it flashes down. What's the price? Like maybe some of the reporters don't actually submit then, and you don't reach consensus on the Bitcoin price.
But in that case, you said, if I understood correctly, in that case, it's not really an issue because you said that the person requesting the price can request where they want the price from. So
they could.
If they say that. So in that case, that I don't think that I feel like that's like a smaller issue. That's more that's less of an. That's more of like a how you request the price versus how the price is reported. I guess the main worries in a setup like this are always the usual. How do you incentivize 2/3 of the validators not colluding in a malevolent manner? And so maybe say something on this.
Yeah, well, I can finish the dispute process quick.
Yeah. Sorry. Yeah, sure.
No, it's cool. Yeah, I mean, the dispute process is relatively simple. So like, let's say a validator over here has, he has 100 TRB staked. So if you would want to dispute him, you would have to match his stake. So what you would do is you would call begin dispute, but we have different levels of disputes. So there are warnings, minor, and major. And so like a warning is 1% of the stake, minor is 5%, major is 100%. This is like he's attacking the system / him, like, but because like most of the time, like a warning, like we've had this issue in current Tellor, it's they're on the bottom side of the median every single time. Like you can't tell, like they're maybe their price quote is half a second old or something like that, and they're just not updating
Right.
it quite. They're probably not being malicious. You just want to send them a warning shot. Like, listen, guys, go fix this because this is causing issues. You know, especially in, like, we've had some protocols that they don't necessarily want to specify exactly where they're getting the price from. You know, they want to just say, like, we want a weighted average of this over time. And if they don't give you specifics, it is up to you, but you know, you want to make sure that this is still a thing. The minor can be obviously a little bit, it's very subjective as far as like which one you want to pick. The major is like, we want to stop this person, we want to stop them from attacking our system.
Right.
The minor is more, listen, you submitted a bad value, don't do that again. Anyway, so what you would do is you would match it. So like a warning of 1%, if the person had 100 stakes, you would need to put up 1 TRB to basically start this dispute. And you can crowdfund it. So you could say begin dispute, and if you don't have the TRB, everybody else could see somebody started this, I want to fund this as well. So you can be part of it. And it would pull it out of their...
But the 1%, so is the 1% what the disputer is putting in, or is 1% what will be slashed?
Well, it's going to be slashed. So it's basically put into a pool, like, you know, you would have like 1 TRB from the staker, and you would have 1 TRB from the disputers over here. You would match them on each side, and then it would go to a vote as far as, okay, should this be a good or bad value. The funding stage, so once you begin a dispute, you have 1 day to fund it. The voting starts as soon as you hit funding, or it fails if it's more than a day. So hopefully, you know, it's just relatively quick. We're actually using the same sort of governance for the disputes as the Tellor system, which is 25% users, so tippers, 25% validators, you know, these guys, 25% the team, and then 25% holders. And we wanted to kind of try and represent all of the stakeholders in the system. And then as time goes on, we can change this, decentralize it more.
So let me get this right. So the tippers are deciding, are effectively setting like a baseline of how much needs to be staked to provide the price for the request.
No, they don't.
No. Okay. So because I guess the one thing I'm thinking about is there could be different reasons for requesting a price, right? In some cases, there may or may not be a lot of money at stake on this price update that's going to come out of the Oracle. So should the staking going behind like an Oracle update be somehow correlated with how much money is effectively depends on this Oracle update being kosher, if you will?
So it's kind of a trade-off.
Granted.
Yeah,
go ahead. Sorry.
So like it's different than the Tellor system currently in that each report doesn't have stake locked specifically to it. You know, like you could report Bitcoin price this round and you could report it the next round, and it's you're using the same stake, right? So you're not like locking a stake with a specific report. We had sort of done the math on that, and it's relatively capital inefficient, especially whenever you need lots and lots of reports. You can't lock up $10 million on each report if you want it every second. It just doesn't necessarily work that way.
Right.
So it's more of like they have a lot to lose, but it's not a specific report necessarily. So it's a little bit different thinking than the other Tellor.
Right. So I guess this kind of connects. I guess this kind of connects on. Well, I don't know. But before I ask my next question, is there anything else you want to add to this dispute? Because you said we're getting to the voting part after. So
so I mean, it's relatively simple. You vote, and either if you hit quorum, so like if 51% of the total of this reaches consensus, like yes, he should be slashed, no, he should not, then it's over. So it's a 2-day long vote, but likely you're going to hit 51%. You could theoretically begin dispute, vote on it, and it's over in, you know, a minute or two if it's relatively obvious.
Right.
And then that's kind of the goal, is because we want to make sure that people can move along and make sure that we're not locking up. This is a good validator's stake, theoretically, even if it's under an attack. So we don't want to lock it up for too long. We want people to reach consensus.
Right, but so from the point of view of someone using the oracle,
yep,
they basically have to factor in also a potential dispute process in terms of time wise, or can they just disregard the time required for a potential dispute? Obviously, disputes don't happen all the time, but if a dispute were to take place, do I, as a protocol using a Tellor as an oracle, do I need to factor in a potential dispute process on any on any oracle request I make?
No, I mean, it depends on if you're a consensus or an optimistic one, I think. So if 2/3 of all the validators signed off on it, you probably don't have to worry about disputes. Like you're not breaking everyone. Like if you did, then the whole Tellor chain's broken. But like you would, but if you are optimistic and only one guy reported on it, yeah, you would want to wait and check for a dispute.
Oh, right. And you said that before, that depending on how many validators sign off on a request, you effectively get notified whether it's a consensus type of output or an optimistic output. Okay, so then my next question, which is the one I was trying to ask before, what kind of incentive mechanism is in place what kind of incentive mechanisms are in place for avoiding a collusion among 2/3 of validators?
So, I mean, I think this is like just the basic, like, why would you not collude to screw over all of your customers type piece? Like you would assume that the voting here is relatively stable, and that basically between the users, the team, the holders, somebody is willing to slash you if you're misbehaving. But this goes back to
my previous question, which is shouldn't the slashing amount effectively or the staking amount be somehow correlated to the monetary value of that specific oracle update? By monetary value, I mean, like how much risk is there? Like, put it this way: if it costs $10 million, I'm just making up numbers here, to get to convince 2/3 of your validators to collude, assuming I can dox them, blah 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 blah.
Right.
But all the complications involved. Let's assume that with all the complications you could possibly think of, getting a collusion to somehow work on Tellor, let's assume it's $10 million, right?
Yes.
That would tell me, as a user of the oracle, is that I shouldn't request oracle updates that have an immediate effect that is larger than $10 million on my platform.
Yeah,
so for example,
that's fair.
Like if the current oracle update leads to a liquidation of $50 million, then there's a disincentive here in place, because potentially you could again, assuming that the $10 million value is correct, you could get Tellor to collude to trigger a liquidation, for example, to cash in on $50 million worth of value.
Yep. So this goes into the user side, which we can get into. The bigger piece about it is like, this kind of goes back to our question on like the sovereign L1 piece. Like,
right.
Why does nobody attack Bitcoin? Why does nobody, why is nobody attacking Cosmos chains whenever they're relatively cheap to break? I think there's different answers to that question depending on which chain you're looking at. Sure.
So I mean, like on Bitcoin is I would say is a special case in the sense that if you attack Bitcoin, the worst you can do is double spend coins that you've owned in the past. This is assuming that the chain state doesn't get rolled back. Where by rolled back, what you really mean is that the chain forks and nodes don't accept the transactions. One could argue that if I am not worried about the double spending of my coins, then I don't care if you're going to double spend someone else's coins. So it's a weird question in Bitcoin, because Bitcoin isn't that complex of a chain in terms of like the smart contract capabilities. On a Turing complete chain, on the other hand, it gets a lot more complicated, because you, especially when involving oracles, because it's if I could manipulate Chainlink prices right now, I could collapse DeFi. Make it completely create like a systemic event in all of DeFi right now, right? Just because of the reach that Chainlink has right now, whether advised or not. So that's why like the considerations behind the incentives to avoid collusion are kind of relevant and are a little more subtle than they are on, let's say, a chain like Bitcoin.
Yeah, no, and I think this is where it comes into like you want sovereignty on this chain. Like you want an ability to fork on this chain. You want, like if you could collude to break this, you with any chain there's going to be a limit to sort of the monetary value of it, and like you sort of want an ability to sort of handle that sort of attack. And I mean, even with a user's protocol, you want to make sure that like you aren't accepting things necessarily instantaneously, or that could break it if you're relying on an answer for $100 billion. Like it's going to break probably Ethereum as well.
Yeah, for sure. Yeah, no, fair enough. Okay, so another question I wanted to ask was, because you mentioned how users can specify what kind of data they want to receive.
Yep.
Instead of just the Bitcoin USD example, I could say I want Bitcoin USD on, you said, Coinbase, Kraken, and Binance, for example. So that leads to an obvious next question, which is data feed onboarding. How easy is it? How does it work? And how does Tellor distinguish itself with regards to other Oracle solutions out there?
Yeah, I mean, so the data feed this is one that I don't think anyone necessarily pays attention to right now. Like right now, whenever people choose an Oracle, they're like, listen, I want an ETH US dollar price. And if you're on this chain and you can do it for me, like the decision is over. Like you have 4 choices, or depending on what chain you're on. And so like it's not like currently like Chainlink says they have trusted data feeds or whatever, but like that's just not how users actually make decisions, because more so it's based on like, are you even on this chain that I'm on, and do you provide this price? But yeah, like I definitely see in the future, like this is a way that we're going to differentiate ourselves, is basically it's going to be like custom and quality data. This is where oracles are going to compete, as far as how do you manage for price feeds, as you said, how do you manage the set of where you get them? Are you volume weighting these things? Are you what tools do you have for outlier detection? Pieces like that, and that this is all going to be built into our software, and like we already have some software built, but it's just one of these things that will be a concern going forward. And the way that Tellor sort of differentiates it is that like you can have multiple different ones. So as we were talking about, like if you want one, you don't necessarily have to use the exact same one that other people do. What we likely see is that probably most people will tend to migrate towards relatively similar things. If you want an ETH US dollar price, you're going to be given an ETH US dollar price. Probably you'll be fine with the one that some big protocol uses on top of Tellor, and you'll just use that. And that's something that basically the chain via the node software is sort of managing. How can you figure out which price feeds that you want to admit, which ones you don't, and hopefully we can sort of prove to everyone we are quality data in that piece. But I think, yeah, like I think as I think as you're hinting at, like I think talking about quality data with users, and like you had even mentioned like the volume and things like that with prices, and this is something that not a whole lot of people think about.
For sure.
Yeah, and because like like most of the biggest issue we face with getting data, especially for price feeds, is like a lot of people have come and they're like, oh, can we have like we have this liquid staking token, can we have the price for it? And you're like, listen guys, this trades on one curve pool. Like that's it. Like, and you're like, we can give it to you, but don't use it like you think
go get it yourself. Yeah,
like
exactly.
go get it yourself. And like, I see how you want to use this. Please just don't. And, um, so like and like most of the time, or lots of people will be like, oh, can we have the price of this token? And you'll see it's like, it's got, 0 volume on Gate and on Uniswap. And you're like, oh man, like, and
Mhm.
it's just a bad idea. So
Yeah.
it's,
I guess though in those cases, I guess like one of the reasons why they like these kind of users approach oracles is simply because they want to have an identical framework for supporting
sure.
let's say price feeds in this example. So instead of like going to build your own custom oracle for all the various assets you want to list, which sometimes we've had to do, by the way, at Ovix and now at Kiom. Yeah, so like for a lot of projects that don't want to go through that hassle, I guess that's the reason behind it is like, let's just ask you to do it, because then I can just like plug in another Tellor Oracle output into, feed it into my protocol. But yeah, I totally get where you're coming from in terms of like, getting white hair out of it when you
Well,
see
I
that
mean,
happening.
and this is a benefit of using a third-party oracle versus like if you don't want to handle governance in your own protocol. One of the issues with like, like as we said, like why wouldn't you just tell the user to go read their own curve pool? And like with us, like we're not the bottleneck in security to this system. So like we actually add security in the fact that like, pray to God you do get an exchange listing. We can easily add that in. We can add in
Exactly.
a pool, something like that, and hopefully make it more robust for you. Or, what we try and convince people to do is like, how about, okay, fine, it is just one curve pool. Let's take a 12-hour TWAP, and then
let's EMA it. Yeah, of course, yeah.
something like that. And so like we can add those benefits in, and that's where I see like the benefits of using not just reading a DEX or something like that. But anyway, so we can talk quality data here in a sec. But like this is a bigger design piece, I think, for users. So like let's say this is ETH over here, and there's some user over on, or let's say it's, we'll call it some roll up over here that wants Tellor data. How do they read Tellor data? And this kind of goes into, so like we'll call this Tellor chain. I know I erased Tellor chain. Layer is the name of the Tellor chain. The way that you read data is, as we were kind of hinting at earlier, it's like client bridges. So
right,
you have a state proof of all of the Oracle data, and you push it over via a like client bridge. Whether right now we have one built that's, we copied it from other people who have done this, and it's not a zero knowledge like client bridge, but in the future we very much see this being a zero knowledge like client bridge.
They're not, of course. So that'll make things so much more efficient.
It'll be way more efficient, and then you can just basically, whenever you're reading it, the cool thing about it is if 2/3 of the validator signed off on it, you can just prove, okay, there's the proof that that data is in that state proof with the Oracle update, and now you can use it in your own smart contract. And that's kind of the meat. And the cool thing about this is that we're updating it once, and you can go to thousands of different chains, and it makes it relatively easy. But yeah, this is the only piece that we have to add over top is kind of as we were talking about. So like in a lot of ways, what this should look like to most people is like, it's like, well, are you rolling up to this chain? Like, like, are you checkpointing to the chain? And in some ways we are. Like, we're going to be like a roll up to every chain out there that we're posting proofs to.
Right.
But the question is,
but the request,
yeah.
Sorry, one question. Sorry to interrupt you. So, but the request is happening to some Tellor endpoint in the rollup, though, from the user's perspective.
Yeah. So there would be like, a smart contract here that you post state proofs to, and then you can read from.
Right. Okay.
So, and then this would be some relayer would have to push this across, but obviously it's a trustless relayer in the sense that anybody can do it.
Right.
Basically just going here and via signature. So there's no way to sort of break it. Um, fingers crossed, there's no way to break it.
Yeah,
What
exactly.
do you say about
Last famous
bridges?
words. No.
Right. Um, yeah, and then but sorry.
No, go ahead. Go ahead.
Yeah, so the one piece that we're trying to add in over top that this is like different. So most people doing this would be like, okay, this is cool. You can just do this, and we'll just read it. But we want to maintain sovereignty. So like, how do we maintain sovereignty if you have a light client bridge and you can't fork? And that's actually the really tough part. And this,
I didn't even think about that. That's a great point.
right, you actually have to add in forking in the smart contract. So this is yeah.
So how does that work? So
this is a design we I say stole, but like we asked him and talked to him about it. If you know Edmund Edgar, from it's Subjectivocracy is the name of the project. He also runs reality.eth. Anyway, so if you want to fork, what you have to do is basically in your smart contract, you basically have some way to pause the system. So like pause and fork. And so in the light client bridge, you would be you give somebody the permissions to pause and then pick a new address that's the new bridge, basically. That we're moving everything over, and this is going to be our proxy. And the way that it works, so like with some chains, like the easy chains are going to be ones with governance. Like if you just have an admin key, you can give it to them and they can do it for you. And then because like most of the times, like this is the problem. Most of the times you fork or like it's under attack, it's usually painfully obvious which one is the right one. Like it's this isn't a contentious fork. It's like, listen, somebody's coming on to attack to break one of your protocols. Let's just pause it and we'll pick the right one. But in the case that there isn't any sort of, let's say it's on Ethereum, how do we handle it on Ethereum? The way that you do it is you have to pay. So pay money to pause the system. And this would be some ungodly number, if a whole bunch of protocols are on it. This would be like a last case resort. I want you to pay $20 million worth of ETH to pause the system for, $20 million, and it has to be done by, one of these 10 guys, trusted parties, like very, very large amount of money to pause the system and then figure out where to go. And then you would put it up, to a vote. Basically, you could either use the way that Subjectivocracy works, this would be customizable based on chains. You could either hand it over to the governance contract itself, or you could hand it over to, like on Ethereum, this would be a great case for restaking. Like what's the few pieces that you should maybe rely on, like the social layer of Ethereum, and it's like maybe fork choice rule on your rollups. Like I see that actually being a valid. I don't like restaking for most things, but this is a very infrequent thing with a very large payout. You can probably beat the social layer for that. And so like you could maybe use a restaking, or you could do like I was saying, Subjectivocracy uses a shelling game. So like just whichever side puts more ETH down wins it outright and gets to pick which side the fork goes, and then you would resume afterwards.
And what happens to the funds?
It would go to whoever, you pay money and this is the reward for shelling or for restaking. You would have to basically, this is the cost of like saving your protocols from something. Yeah.
Cool. Well, this is this seems to be like the tricky bit of the entire mechanic.
This is, yeah. No, this is one of those things like I don't see. This is one of the things I could feel like Layer almost being used for other projects. Like when you have all of these light client bridges, but you want to maintain some semblance of forkability. Like, like how could you ever prevent an attack like this? And somebody's like, I think these are the kind of systems that people are going to need to put in place. Like you know, like, because God forbid there's some bug over here or on any chain, like if we're assuming that no chain can ever have a bug, it's going to lead to a whole bunch of problems. You know, if we have thousands of app chains. So like, I think having these pausing, forking things where it sort of then goes back to your consensus to, as I said, in most cases, painfully obviously pick the right choice. You know, the one where Bitcoin is not $20 million as reported to the Oracle, and then you can sort of move over.
Right.
But yeah, this is like, this is a big piece of it, and this is I think probably more of the controversial piece to what we're doing, if you would, as far as trying to push for like max decentralization, max sovereignty over the chain.
Yeah. I mean, so I guess connected to the whole restaking, it kind of made me think of asking you about how this whole setup, how would this compete with a potential future where validators act as oracles?
Yep. Well, I mean, I think like Vitalik has sort of pushed this to most people's forefront. So like the one piece would be like, so like, let's say you have this validator chain. So like, this is how like DYDX would work. Like the validators themselves are the oracles on the DYDX chain. And that can work fine for certain pieces. The problem is it's like, what are you willing to slash your validators for? And how, yeah, like, what do you want to lean on the social layer for? Because this is most of the times, like if you're doing oracles, like Ethereum, people have always pushed for Ethereum. Like, can you at least just push an ETH US dollar price? Like, this would be great. And as a lot of the ETH researchers have put it, like, if we can't come to consensus on an ETH US dollar price, are we halting the chain? Are we, are we preventing finality on the chain if we can't decide which exchange is the correct ETH US dollar price? Maybe, maybe, but they said like, we actually don't want to do that, and we actually don't want to do that for every asset and be the oracle. And like this is one where Tellor is, like, that's kind of why we allow for this optimistic thing, where we say the validators don't have to report on everything, because if you force them to report on everything, they won't do it, because like some things you just, especially even with prices are an easy example. Like sometimes there isn't an answer to what's the Bitcoin price at the current moment. Like there are scenarios where that doesn't hold. And what do you do in that case, and how do you handle it? Is kind of going to be, that's going to be the big question. But
yeah, for sure. I mean, price is a very abstract. It's a very abstract concept in this sense, because a protocol uses a price, depends on a price for certain operations. And this whole, it's all based on the assumption that a price exists, different A,
right.
One's A. And the reality is that a price doesn't really exist many times. You can have very different situations happening on different price sources, whether it be due to hacks, whether it be due to weird market operations, whether it be due to sudden jurisdictional influence of whatever kind. So yeah, that's why. I mean, I personally, based on your entire exposition, I personally like the fact that you guys allow potentially users to specify what price they want. And like give more. I agree with you that the vast majority of users are not going to do this. They're just going to give me the Bitcoin price. I totally agree with you on that. But the fact that by design you allow users the option to set what kind of, like, the definition for what it is priced, what price is to them, I think is a huge bonus. Just in terms of flexibility and of operations. So I really like that a lot.
And onto your, like, back to your other question too, of like why other chains won't. Like, I do see, like let's say there was like a stable coin chain or one of these pieces, and like, why wouldn't they just run their own validators? I think one of the pieces you run into is that there's a conflict of interest for oracles on those chains. Like this actually happened with Maker. So Maker was accused of this back if you remember, I think it was like the 2020 flash crash. Everything went down like 50%. And Maker knew it was going to liquidate a whole bunch of people, and their oracles were a little bit slow on that one. And like this is, it's just one of those things.
I remember something very similar happening also to a very big Celsius position on Aave, a staked ETH position on Aave, and was in spring of last year, where the Chainlink price feed coincidentally went stale just at the right time to avoid getting that position liquidated. And you never understood. Nobody ever knows if this is coincidence or not, right?
So I mean, like, and maybe like if you want to say sovereignty of the chain, like you could argue that, but like I think for a lot of reasons it makes sense. Like there might be a conflict of interest if your validators are also your oracle. So
right,
users of there should keep that in mind.
Right. But then I would. This also begs the following question, which I wasn't going to ask, but I guess it makes sense at this point. Yeah. Is the data redundancy aspect, right? Because if everybody is getting their prices from the same exact place, you may have like the most diverse decentralized validator set in the world, but you have a single point of failure, which is the manipulability of the one data source that they're all reading,
right?
To quote the price.
Yeah, I mean that's the piece of like, the most secure price you can get is to where you just say like, give me a Bitcoin price. It's not going to be nearly as accurate or like within, precise as far as what you get, but at least you can tell like you're going to probably have a vast array of data sources that reporters are choosing from.
Fair enough.
Whereas
I see what you mean.
Yeah.
Whereas if I ask for a specific price source, then I can run into the problem where I lose out on the decentralization of the validator set. But then I got to ask the question. I apologize for this can be a super technical question.
No.
So you get a distribution of prices. When I asked for the Bitcoin price, right? So I get a distribution of prices from all the validators, right? So in terms of slashing, do you guys have like codified a specific like amount of standard deviations from the mean beyond which you consider the price to be a bad price? How is that? Because if I just ask for a Bitcoin USD price and we agree that Bitcoin USD price can potentially be very different things, then you're going to get like a distribution of Bitcoin USD prices, which arguably is going to be peaked near what people intuitively think of the Bitcoin USD price. But then how do you define outliers? Like how do you codify outliers?
You almost have to leave it subjective in a lot of ways, because it's very dependent on what the asset is, what the volatility is even at the time. Right. If it's a crazy Bitcoin market day and the price is moved by 50%, you're going to have standard deviations all over the place. Whereas if it's super flat and you're one standard deviation off, like that's wrong. Like it's just easy to say that's wrong. 99% of people.
So is that the definition? Like one standard deviation?
No, there is no definition, and I think that's by purpose. Like you want to leave it up to the subjective layer that this is our job, of the validators and disputers to think hard about like this sort of what is.
So in a dispute, like the validator decides to dispute a specific price given by the ensemble, and then they all vote on whether they want to think of that price as like a natural price to come out of the distribution of Bitcoin prices or an unnatural. Okay, got it. So that depends on. Interesting. So that completely depends on the validators also. So they're effectively continuously defining kind of like the margin of error on the Bitcoin price, right? As they report the price. Okay.
Yeah. Okay. And I mean, for us, like it's one of these things. Like if you get a price where 2/3 of the validators are sort of submitting for it, it's great because like if people are off on the margins, you can work with it over time and those warnings and things like that. Whereas, the thing that you're really worried about preventing is like, obviously wild swings or attacks more so than, the little errors.
And how, so in terms of percentage wise, like how tight is the distribution of the of prices reported by your validators?
Usually they're really, really tight. I mean, most of the time it's very tight just because most of the people are getting it from roughly the same sources. As far as, like Bitcoin prices, most people will check the coin market caps, the coin geckos, trading around there. So it's not more of the problem with like Ethereum is, and the distribution comes in that you have longer block times. And so you don't know exactly when the person submitted it.
Interesting. So there's no specific incentive to have validators report prices from a diverse set of price sources.
No, I mean not necessarily. We do currently with Tellor like the way is you have a bunch of different clients. People are running different ones, and but we actually can't tell where people are getting them from. So, like there's nothing to say like we can't necessarily incentivize it because we don't know. I guess we can't actually tell.
But the validators have to. But the validators have to. So the validators don't have to say how they're getting the price, how they're calculating the price, and
no.
So I could join. I could join as a validator for Tellor, and I could do like a TWAP of futures implied Bitcoin spot prices, and submit them alongside all the other validators, and that would be considered kosher.
Yeah, I mean, you're subject to a dispute if that goes awry. That strategy goes wrong, but yeah, theoretically.
Right. Yeah. Right. Okay.
So,
okay. Fair enough. Awesome. So, and I guess we're over an hour in at this point. to wrap it up, I wanted to ask you like the last question, which actually is the question I was most interested in. Just like kind of like, could you summarize? Because again, and I said this in the introduction at the beginning of the deep dive. One thing that I think I really appreciate about the Tellor project, and I think if viewers aren't aware of this, they should put in some effort to appreciate themselves, is the focus that you guys put on decentralization. Because decentralization, unfortunately, in the space is thrown around as just like a buzzword without any meaning behind it in like even the vast majority of cases. Whereas if you think deeply about it, it has very important meaning and very important consequences when applied properly. So would you like to summarize like the guiding principles that or some general rules sets that you guys keep in the back of your mind to help you when you approach complex trade-offs, which in your case are particularly complex because you're dealing with this multi-agent system right to begin with, that it potentially can underpin very significant consequences when applied in certain contexts, such as DeFi, where a lot of money is at stake at any given moment. Just give your ode to decentralization, Mr. Fett.
Yeah, I mean, it's a great question. I think it's kind of the reason we're all here. The reason is you're building these decentralized apps, you're building these censorship-resistant things, not because it's efficient, not because it's fast and can compete with centralized exchanges. These are things that are supposed to be sort of freedom enhancing. Like I originally got into the space with like kind of the Ron Paul movement here in the US and the libertarian aspect of it, and ending the banks. And like we're not necessarily still on the target of ending the banks, but you have this idea of, the beauty of DeFi and the beauty of cryptocurrencies is that anybody can sort of partake. Like there's no gatekeeper, there's no one that can keep you away from your money or slash you. And that's kind of what we're looking to do. Like we put a big focus on like how can we make it so nobody can shut down Tellor. How do we make it so okay, no one party can control it, the government can't come to us and tell us to shut it down. And those are the kind of projects that we're hoping to be with. Yeah, so I don't know, hopefully that was a good answer.
Functionality for enemies, basically. Like the way I like to think of it myself is just if two existential enemies can agree to use your project, you've done decentralization properly.
For sure.
If not, you're not as decentralized as you probably should be. So with that, I'd like to thank you, A, for having me do this, because this was really fun, and B, for having given us such a wonderful exposition of the entire project. And I think we're
cool.
I feel like we're all rooting for the success of it.
Awesome. Well, yeah, no, we'll have to do it again in a little bit. But anyway, thanks everyone.
At the pace at which you build stuff, for sure. All right, thank you, everybody.